Hello, ladies and gentlemen. This is Mrs. Stanis here, presenting to you Saxon, Lesson 70, which is about reducing fractions before multiplying. So please have your note sheet in front of you and a pencil in hand. Put your name on top, and we are going to begin. Now, the top of your page might have a problem-solving practice that looks like this. We are going to skip that, so you could just cross it out, or you could actually solve it if you want to for fun, but we're not going to be doing that in this lesson today. So we're going to skip ahead to right here, where we've actually talked about this before, reducing fractions before you multiply, but this is the official lesson. So what it says here is before two or more fractions are multiplied, we might be able to reduce the fraction terms even if the reducing involves different fractions. For example, in the multiplication below here, we see that the number 3 appears as a numerator and a denominator in different fractions. So let's just do this the regular way. 3/5 times 2/3. We would multiply our numerators. You get 3 times 2 is 6. And then you multiply your denominators. 5 times 3 is 15. Then you would reduce 6/15. So we would do that by dividing by 3, which is the GCF of 6 and 15. And 6 divided by 3 is 2. 15 divided by 3 is 5. So 2/5 is the answer to that multiplication problem. It's the product. Now, what you can actually do, and this is a great, I guess, shortcut we want to call it, that's going to help you if you remember to use it. What you can do is reduce the common terms, the 3's, that would be, before multiplying. So you can reduce before you multiply in certain multiplication problems. So we can reduce 3/3 to 1/1, of course, by dividing both 3's by 3. So 3/3 we know equals a whole. So let's cross out the 3's and turn them into 1's because we know 3/3 equals a whole. Now we multiply the remaining terms. So 1 times 2 is 2, and 5 times 1 is 5. Notice we get the same thing, 2/5, but this way the terms were reduced before you multiply. And this way you had to reduce afterwards. So you might be asking yourself, okay, why would I want to do that? There's a couple reasons, and we're going to get to that a little bit later in the lesson, but I want you to start thinking about that now. Why might you want to do this, okay? And we'll talk about it officially in a little bit. So here it says, sometimes we can reduce the numerators and the denominators of both fractions. So it doesn't just have to be like in that case where just one fraction or like, the 3's were the only things that were canceled. Here you can see we don't have the same numbers in either case, like 4 and 8, 3 and 9. But however, if you think of 4/8 as a fraction, what is 4/8 reduced to? You should be able to come up with 1/2 pretty easily. So we can make the 4 into a 1, the 8 into a 2, because 4/8 reduces to 1/2. Now going the other way, 3/9 is another pretty easy fraction to reduce. 3/9 equals 1/3. So we can cross off the 3 and make it a 1, cross off the 9 and make it a 3. Now multiply the remaining terms. 1 times 1 in your numerator is 1. 3 times 2 in your denominator is 6. So the answer is 1/6. Now I want to just back up. Let's say we did this the old way. 4/9 times 3/8, you would get 12/72, which if you reduce, you could divide by 12 and you would get 1/6 because 12 times 6 is 72. You get the same thing, but in my opinion, this top way is a little bit easier because 12/72 is not such an easy fraction to reduce. Is it impossible? No, but it's just a lot tougher than 4/8 and 3/9, for example. Now it says down here, caution, when canceling, a numerator must be paired with a denominator, not with another numerator. So I'll give you a quick example of that. Let me get another page. Okay, so if we have something like 4/7 times 4/9, you can't cancel these 4's. That wouldn't make sense because 4/4 does equal 1, but one of the 4's has to be a denominator for it to be 4/4. So you can't do that. Okay, don't try that. That doesn't work. The numerator has to be paired with a denominator. All right, moving on to the next example. Example 1, actually. It says simplify 5/6 times 1/5. So let's simplify or reduce before we multiply. Notice across diagonally here we have 5/5, which equals 1. So we can just cancel out the 5's. And then we get 1 times 1 is 1, and 6 times 1 is 6. Ta-da! Now, if you want to try it the old-fashioned way, is what I'll call it, you can see that you would get 5 over 30, which also reduces to 1/6. So let's try example 2. And again, feel free to pause the video and try it on your own for any of these. So we have simplify 1 1/9 times 1 1/5. So remember, with SOS, what we need is fraction form to shape our fractions. So 1 1/9 we have to turn into an improper fraction, and the same thing with 1 1/5. We have to do that before we multiply. So to turn this over, we would say 9 times 1 is 9, plus 1 is 10. So 1 1/9 equals 10 ninths. And for 1 1/5, 5 times 1 is 5, plus 1 is 6, 6/5. And now we're going to reduce before we multiply. So I notice if I look diagonally, I have 10 and 5. Well, it's an improper fraction, 10/5, but we can reduce it. 10 divided by 5 is 2. So we can make this 2 over 1. And going the other way, 6/9, I can recognize that pretty easily as the fraction 2/3. So I can make 6/9 into 2/3. Now I will multiply, and I get 4/3, which of course then, that was my operate. Now I got to simplify. 4/3 equals 1 1/3. And that's my answer. So there you have it. Now it says here, officially, why might you want to reduce before you multiply? You can put whatever answer you feel is best. Now, in my opinion, I think it's easier to work with smaller numbers when reducing than to work with bigger numbers. So I'm going to write that just quickly. It's easier, and you can write what you want to say, but it's easier to work with smaller numbers. There's less risk of making an error, reducing 6/9, for example, than reducing 12 over 72. So let me just show you if we had done this the other way. 10/9 times 6/5, you get 60/45. Now that's not horrible to work with, but it's a lot easier to reduce something like 4/3 and 10/5 and 6/9 than it is to reduce 60/45. I think it's less risky, less chance of making an error, so that's why it might be easier to do it this way. I truly feel this is easier. So it's a great lesson for you guys today. Okay, example 3, simplify 5/6 divided by 5/2. So we're doing a division problem. It says, can you cancel factors in division? Well, no, because there's no such thing as factors in division. But we know division problems are really multiplication problems. If we use keep, change, flip, or the rhyme to divide by a fraction, don't ask why, flip the second fraction and multiply, we would keep our first fraction the same. We change the operation to multiply, and we flip the second fraction. We get the reciprocal. So you're really doing 5/6 times 2/5. Now we can actually reduce before we multiply. So 5/5 cancels out, and they become 1s, and 2/6 equals 1/3. So we'll make this 1/3. And we multiply. 1 times 1 is 1, 3 times 1 is 3, and the answer is 1/3. That's the quotient to this problem. Okay, so that is a great trick that is going to help you out through the rest of your math career. I hope you remember to use it. And now you're going to apply that to the practice set right now. Reduce before multiplying for A and B. For D and E, you're going to have to write them in fraction form first, then reduce before multiplying. And then for G and H, you're going to have to, of course, do the keep, change, flip, and then reduce before multiplying. So try these out now, and we will check them in class. And thank you for listening.